Caliper. In our daily life, we use meter scale for measuring length. They are calibrated in centimeter and millimeter. The smallest length which can be measured by meter scale is called least count. Usually, the least count of a scale is 1 millimeter. We can measure the length of objects up to 1 millimeter accuracy with this scale. By using Vernier caliper, we can have an accuracy of 0.1 millimeter, and with a screw gauge we can have an accuracy of 0.01 millimeter. 0.1 millimeter is the least count for Vernier caliper. 0.01 millimeter is the least count of screw gauge. A description of Vernier caliper. The Vernier caliper consists of a thin, long steel scale graduated in centimeter and millimeter called main scale. To the left end of the main scale, an upper and a lower jaw are fixed perpendicular to the bar. These are named as fixed jaws. To the right of the fixed jaws, a slider with an upper and a lower movable jaw is fixed. The slider can be moved or fixed to any position using a screw. The vernier scale is marked on the slider and it moves along with the movable jaws and the slider. The lower jaws are used to measure the external dimensions and the upper jaws are used to measure the internal dimensions of the object. The thin bar attached to the right side of the vernier scale is used to measure the depth of hollow objects. Finding zero error of Vernier caliper. Unscrew the slider and move it to the left such that both the jaws touch each other. Check whether the zero marking of the main scale coincides with that of the zero of the Vernier scale. If they coincide, then there is no zero error. If they do not coincide with each other, the instrument is said to possess zero error. In the first picture, there is a no zero error. Zero error may be positive or negative. If the zero error of a vernier is shifted to the right of the main scale, it is called positive error. On the other hand, if the zero of the vernier is shifted to the left of the zero of main scale, then the error is negative. In the picture B, second diagram will be having positive error. Third diagram will be having negative error. How to measure the diameter of the hollow object with the help of Vernier caliper? Now we will check. To measure the external diameter of the hollow object or outer diameter of the hollow object, we have to use lower jaws of Vernier caliper. Place the object in between the lower jaws. Now the Vernier scale readings will be moved over the main scale reading. Then we can take the readings. For measuring internal diameter or inner diameter of hollow object, we can use upper jaws of Vernier scale. Upper jaws of Vernier scale we can use. With the help of the upper jaws, we can measure the inner diameter of the hollow object. To measure the depth, we can use the rod which is placed right side of the Vernier scale, that is the thin bar attached to the right side of the Vernier scale is used to measure the depth of the hollow object. The yellow color readings called main scale reading, the red color readings is called Vernier readings. Now we will check how to take the readings in Vernier caliper. Now how it work we'll check now. Place any object between the jars. When you place any object between the jars, the readings will be moved over the main scale. Now check the position of the zero of the Vernier scale, which is past 3 millimeter in the main scale. So the main scale reading is 3. Then you have to take the coincidence of the Vernier scale to the main scale. Coincidence reading is 6. Finally, the reading is 3.6 millimeter. Digital Vernier caliper. We are living in a digital world, and the digital version of the Vernier calipers are available nowadays. Digital Vernier caliper has a digital display and the slider, which calculates and displays the measured value. The user need not to calculate manually. The least count, zero error, and the formula no need to use. We can take the reading directly from the display. Thank you, students.
Good morning, my dear students. Welcome to the chemistry online class. Previous class we discussed sublimation method, centrifugation method and solvent extraction method. In this class we move on simple distillation method. First, what is distillation? Distillation is a process of obtaining pure liquid from a solution. So distillation is a process of obtaining pure liquid from a solution. Distillation is actually a combination of evaporation and condensation. So distillation is a combination of evaporation and condensation. Next, what is evaporation? The process of a liquid changing into a gas is called evaporation. So liquid changing into gaseous state is called evaporation. Next, what is condensation? The process of a gas changing into a liquid is called condensation. So changing state from gas to liquid is called condensation. For example, seawater in many countries is converted into drinking water by distillation method. First we discuss simple distillation method. This method is also used to separate two liquids whose boiling points differ more than 25 Kelvin. So boiling points differ more than 25 Kelvin. This is the apparatus setup. A distillation flask is fixed with a water condenser. A thermometer is introduced into the distillation flask through an one-hole stopper. The bulb of the thermometer should be slightly below the side tube. The brackish water, that means seawater, is taken in a distillation flask and heated for boiling. The pure water vapor passes through the inner tube of the condenser. The vapor condenses into pure water, that is called distillate, and the pure water is collected in a receiver. The salt are left in the flask as a residue. So we are taking the seawater in a distillation flask and we are heating that mixture. The pure water vapor passes through the inner tube of the condenser, so that the condenser will condense the vapor to liquid. So the vapor condenses into pure water and the pure water is collected in a receiver and the salt are left in the flask as a residue. So students, now we know about simple distillation method. So next we move on fractional distillation. This method also used to separate two or more miscible liquids whose boiling points is less than 25 Kelvin. So boiling points, the difference is less than 25 Kelvin. But simple distillation method, boiling points, the difference is more than 25 Kelvin. So the 2 points you remember. In simple distillation, boiling point difference is more than 25 Kelvin, but in fractional distillation method, immiscible liquids, that the boiling points, the difference is less than 25 Kelvin. For example, we are separating acetone and benzene mixture. You know, the boiling point of acetone is 329 Kelvin and the boiling point of benzene is 353 Kelvin. The difference between these boiling points is 24 Kelvin. So students, you know, less than 25 Kelvin. So today we separate acetone and benzene mixtures by using this fractional distillation method. So first, a distillation flask is fixed in between the fractionating column and a water condenser. We take the liquid mixture of acetone and benzene in a distillation flask and heat it for boiling. We know boiling point difference is less than 25 Kelvin only. So boiling point difference between acetone and benzene is 24 Kelvin only. So this fractional distillation method is suitable to separate these two liquid mixtures, acetone and benzene. So we are boiling these mixtures. The vapor passes through the fractionating column, which liquid has lower boiling point. It boils first and the vapors will condense and is collected as first fraction in the receiver. At a temperature of 329 Kelvin, acetone distills out and is collected as first fraction in the receiver. When an acetone is distilled out completely, the temperature starts rising and the receiver is changed. When the temperature becomes 353 Kelvin, benzene distills out and is collected as second fraction in the receiver. Acetone and benzene can be further purified by redistillation using simple distillation apparatus. So fractional distillation is used in petrochemical industry to obtain different fractions of petroleum. Next, what are the differences between simple distillation and fractional distillation? In simple distillation, two liquids boiling points differ more than 25 Kelvin. But in a fractional distillation method, when the difference in boiling points is less than 25 Kelvin, and simple distillation method, it consists of simple apparatus setup only. Two flask, distillation flask and Honeckal flask and a condenser. But in a fractional distillation method, it consists of more complex apparatus with fractionating column. And in simple distillation method, for example, we can purify seawater. In fractional distillation method, refining of crude oil. So students, now you understood simple distillation and fractional distillation. The main difference between simple distillation and fractional distillation is, in simple distillation, that a liquid's boiling point difference is more than 25 Kelvin, but in a fractional distillation method, that variation is less than 25 Kelvin. So students, thank you. Next class we study chromatography technique.